How to solve a trig equation by Claudia Amadeo. Before we get started, there's some things we need to know. Some special triangles, for example. Number 1, it's a 30-60-90 triangle and it's being drawn. Number 2 is our 45-45-90 triangle and it's also being drawn right now. These will help us solve our equations. Now we need to know about the unit circle. It has a radius of 1, and these are some key points being drawn in. As you can see, here it's 0, 2 pi, pi over 2, pi, and 3 pi over 2. Today we're going to be solving 2 cosine squared x plus 3 sine x minus 3 is equal to 0. Our domain is x has to be between 0 and 2 pi. So let's get started. Our first step is to figure out what we can do. We can use the Pythagorean identity because we have a cosine squared x. The Pythagorean identity states that sine squared x plus cosine squared x is equal to 1. Therefore, we can turn our cosine squared x into 1 minus sine squared x. And now we can substitute our simplified cosine squared x value into our equation. So our parentheses here signify one thing, simplify. We're going to expand our parentheses and we're going to get, we now see a like term between the 2 and the negative 3, and that'll just simply simplify to minus 2 sine squared x plus 3 sine x minus 1 is equal to 0. So now to simplify even further, we can just multiply our whole equation by a negative 1 to make things a bit easier. Now, what do we have here? A quadratic. We can take our a and c values, which come out to 2, and our b value, which comes out to negative 3, to factor. Negative 2 and negative 1 are the values that multiply to 2 and add up to negative 3. So now we're going to use those values and rewrite our equation so we can factor. So now we simply factor. Just take a 2 sine x out, and we end up with this. And here we're going to take a minus 1 out, and we end up with this. So as we continue to try and solve for x, we're going to set one of our groups that we factored to 0. And we end up with sine x is equal to 1/2. So this is when our special triangles come into play. We're going to use the 30-60-90 one because it has a 1 and a 2, and our answer is sine x is equal to 1/2. Following SOHCAHTOA, sine means opposite over hypotenuse. We have to find an angle that's opposite is 1 and its hypotenuse is 2. The only possible answer is 30 because its opposite is 1 and its hypotenuse is 2. So now, the angle 30 in radians is pi over 6 because pi is equal to 180, and over 6 that would make 30. Now we refer to our unit circle. The unit circle has 4 quadrants, 1, 2, 3, and 4. In the first quadrant, all values are positive. In the second, sine values are positive. Third, cosine values are positive. And fourth, tangent values are positive. Since we have sine x is equal to 1/2, and that's a positive value, we're going to be focusing in the first and the second quadrant, and that's where our answers will be, since sine is positive. So now, again, 30 degrees is pi over 6. We're going to find pi over 6 values in the first and second quadrants because our sine x value is positive, and in the first and second quadrants it's positive. So it's pi over 6 in the first one, and then 5 pi over 6 in the second one, because those are our pi over 6 values where sine is positive and 1/2 is positive. So now we're going to take our second group from our factoring and set it equal to 0. So we get sine x is equal to 1. So since this is a special value, we're not going to use a triangle. We're going to remember our very important values on the unit circle. We can remember that cosine is the x value and sine is the y value. So then we're going to find where sine of x is equal to 1, and it's at pi over 2 because of this special point. Therefore, sine x is equal to 1 and x is equal to pi over 2. So in conclusion, we can refer back to our domain and see that all our values found for x are between 0 and 2 pi. So we're correct. Thank you for watching, and I hope you understand now.